Navier-Stokes problems can either be solved analytically or numerically, and I will now walk you through the steps for solving the problems in both of those ways. So as far as solving problems analytically goes, the first step you're going to want to do is list your assumptions. This will be very important as the assumptions will allow you to simplify the mass and momentum balance equations for Navier-Stokes problems. Then you're going to want to determine what the boundary conditions are. And these boundary conditions fall into 3 different categories as far as main boundary conditions that are used go, and those are no slip, they are symmetry, and shear. The next step is to simplify the overall mass balance, and these simplifications will come from the assumptions that you've made, and then that will be directly followed by simplifying the momentum balance, which will also be simplified according to the assumptions that were made. Then you'll want to solve the momentum balance, and this step is a little bit more complicated as this often comes from 2 separate integration steps if needed, and both of those, the constants that will come from them will be determined using your boundary conditions. And once this is complete, you will find yourself at your analytical solution. And that will be in the form of some form of velocity profile, if that's what the question is asking for. Next, as far as solving problems numerically goes, you'll follow the same steps for 1 through 5 if needed, and then you're going to want to determine if the problem is first order or second order, and this will tell you what kind of differencing equation you need. So if it involves a first order derivative that you're trying to solve, you'll either use a forward, backward, or centered differencing equation. The forward differencing equation shown here, backward here, and centered here. As far as choosing whether or not you use forward, backward, or centered equations, that's going to be very problem dependent, and there's not always one method that is the most accurate. So that is something that will be based on the problem that you're doing. If the problem is second order, you'll use this equation right here, which does not have any sort of forward, backward, or centered label to it. Next, you just need to plug in known values to solve, and this can either be done by hand or with Excel for more exact measurements. And after doing that, that will get you to a numerical answer for a Navier-Stokes problem.